Okay, now look, told you, equilibrium constant K not going away. So you want oxidation of iron by H+. And it doesn't say oxidation of iron, which iron. So I'm going to say, so here H+, this is the She, standard hydrogen electrode. And I'm going to use iron 3 just because I can. So oxidation of iron. So this is telling me that my oxidation step is going to be iron going to iron plus 3. Now, this does not say which iron. I'm using plus 3. You could do this with plus 2. It is okay. So if oxidation is iron by H+, so H+ is getting reduced. I'm using this one because it illustrates the equation a little bit better. It's more straightforward when you have, here we go, plus 2 electrons is going to make H2. Now, what we need to make sure here is we need to balance these electrons. So do you see how this is not balanced? So we need to, so see, redox doesn't really go away. So our final overall reaction would be 2Fe plus 6H plus 6 electrons, making 2Fe plus 3, 6 electrons, and 3 H2s. So this is the number we need because we need to deal with our moles of electrons. Now, before we do any of that, we need to calculate our cell. Now, when it says use the table, we have to be at standard conditions. Oxidation occurs at the anode, reduction is a cathode. This is the She. And iron 3 is right below it, negative 0.036. So 0 minus negative 0.036. And if you don't want to show that, that's fine. Okay, so now, again, this is an equation I will give you. So we're just going to plug and chug. Standard cell potential equals, again, we talked about where this number comes from. Don't worry about it. 592, and that's really like volts, which I guess I didn't really need that, but divided by N times log of equilibrium constant. Okay, so, oh yeah, I didn't need my cell here. So here, 0.036, and here you can put volts here. That's where that's going to cancel out. 0.0592 volts. Now, in number moles of electrons, in this case, it's 6. And here, that's going to be log K. So let's go ahead and get a number here. So 0.036, I'm going to multiply by 6, and then I'm going to divide by 0.0592. All right, so I get log K equals 3.65. Now let's go with, how about 649, if you want. Okay, so now to get K, that's going to be 10 to that power. So let's say 10 to the power of that answer. So we get 4453. So this is a very high equilibrium constant. It very much favors the products. It's going to be a pretty spontaneous reaction.